Part 2, this is for questions 7 to 11. Question 7, part A, write down the first 4 terms of the expansion in ascending powers of x of this one here. Now we know that for the binomial expansion, let's say we have a plus b, then to the power of n, we say n combination 0, then a to the power of n, then b to the power of 0. The power of the b is the one that goes into the combination. Now for the next terms, a, the power of a keeps on reducing as the power of b increases by 1. So n, then combination 1, then this one is a, n minus 1, b picks that power, then n combination 2, a to the power of n minus 2, then b to the power of 2, and then it continues until the power of a becomes 0 and the power of b becomes what? N. Okay. This one is so for this n being a positive integer. If it's a negative integer, this expansion will never end. Okay, it's an infinite series. And also if it is a fraction, it never ends. Okay, now let's go to this one here, a minus x, then to the power of 6. So our n is 6, now combination 0. Then our a is still a, then to the power of 6. Our b is now negative x. Please take the sign with the x. Then to the power of 0, then 6 combination 1. Then we have a power 5. Remember, it keeps on reducing. Then this one is power 1, 6 combination 2, then a to the power of 4, and then now minus x to the power of, this will be 2. Remember, when you add these powers, okay, you get the n that is given, okay? Then plus, this will be 6 combination 3, then a to the power of 3, and then negative x to the power of 3, and many other terms. But I will stop there because they said we do the first 4 terms. This is the first, second, third, and fourth. So this one is going to be a power 6, okay? That is a power 6. Then 6 combination 1 is 6 times the negative 1, that will be minus 6. Then a power 5, and then x to the power of 1. Then 6 combination 2 is 6 times 5, that is 30 divided by 2, that is 15. And then the square of the negative becomes a positive. So here we shall have positive 15. Then a power 4, x what? X squared. Even power of a negative is always a positive, right? Then odd power of a negative is always a negative. That is why you are still seeing the what? The minus here. Then 6 combination 3. What do you have here? 6, then combination 3. That one gives us 20. So we shall have this 20. Odd power of a negative is a negative. So we shall have minus 20. Then a power 3, and then x cubed, and the rest of the terms. But the first 4 they wanted are these ones here. Then part B, given that the coefficient of x squared in this expansion is negative 20, find in exact form the possible values of the constant a. Okay, now from here, remember all the terms, this one and then the 2 over ax in the first bracket, they are going to multiply with all the terms that are in this second bracket here. So this simply implies that we are going to have 1 plus 2 out of ax. I'll just bring whatever I've gotten here, then I put it here. So we have a power 6 minus 6, then a power 5 of x, then plus 15 a power 4 of x squared, then minus 20 a cubed, then x cubed. So like that. But then we are not going to expand this. It is wastage of time. We just need the terms when multiplied. They are going to give us x squared. They are going to end in x squared. So that means this one here is going to multiply with this term here. You see that? Then this one here, which is 1 over x. So 1 over x must multiply with x cubed such that you end in what? X what? Squared. You see that? So that means 1 over this one here, this term has to multiply with this one here. You see that? So we shall say that the term in x squared is going to be 1 then times the 15a power 4 then x squared, and then plus this one here is going to be 1 over it is 2 out of ax then times negative 20 a cubed then x cubed, like that. So we simplify this one will be 15a power 4, and then what shall we have? I think this one will be a minus. Now this one will reduce this to x squared, right? Then this a will go into this one, and then we get a squared there. Then 2 times the negative 20, that will be negative 40, not so. So that means here we're having negative 40, then a squared, then x squared. So this is the coefficient of x squared here. So they said it is equal to negative what? 20. So I will say that 15a to the power of 4 minus 40 a squared then is equal to negative what? 20. Then I will bring this on this side, and we shall have 15a power 4 minus 40 a squared then plus 20, which is equal to 0. This is a quadratic equation in a squared. Okay, so let us see whether this one is factorizable on the calculator. Mod, then equation is 5, and then quadratic is 3. Then I'll put 15, then minus 40, then 20, then we get 2, and then 2 over 3. 2, then 2 over 3. So I would say a squared is equal to 2 over 3, and also a squared is equal to 2. Okay, remember it is a quadratic in what? A squared, but you need to show the examiner the attempt to solve the quadratic equation. So cross multiply such that you get a factor from which your values here come. Okay, so when I cross multiply, I will have 3a squared, then bring the 2, that will be a minus 2 there. And then the same thing you do here, just bring this one here. You have a squared, then minus 2, which is equal to 0. By the way, when you get this 3a squared, then times the a squared, you will get 3a power 4. Okay, but then this one is 15. Now that means we put out a 5 here. So the 5 is there. So when we multiply this by 5, actually 5 is common all through. So when you divide all through, here you get 8, negative 8, then here you get a 4, and then here you get a 1, a 3. So that's why you get a negative 2 times a negative 2, and then it gives you the positive 4, which you get after dividing all through by 5. So maybe to make things clear, you put a 5 there. Okay, then our a is going to be the square root, so this will be plus or minus the square root of 2 out of 3. Okay, and then also here a is going to be plus or minus 2, and they said exact values, so we leave them there like that. Question 8 is coming from functions. They are saying functions f and g are defined as follows. F of x is equal to x squared minus 1, and it is valid for x less than 0. Then g of x is this one here for x less than a half. Part A, solve this equation here. So this is a composite function. I'm going to put g of x in the place of x in the f of x. Okay, so I'll have g of x here. I'm going to have something like this: g of x, then squared, then minus 1. Okay, where there is x, I'm putting what? The whole of the g. Then subtract a 1, then this one is equal to 4. So this will be 1 out of 2x plus 1 squared. Then this one will be equal to, when you take this on this side, it adds to 3, and then we get a 4, not so? Then we take the square roots on both sides. When I take the square roots on both sides, of course this one will go, then we shall have 1 out of 2x plus 1. Then this one will be equal to plus or minus 1, 2. So if I have 1 over 2x plus 1, which is equal to 2, and then I also have 1 over 2x plus 1, and this one is equal to negative 2. So when we cross multiply, we shall have 1, which is equal to 4x, then plus 2. Bring this on this side, it subtracts from a 1, and then we shall have negative 1, which is equal to 4x. So that means x here is going to be equal to negative a quarter. And then when I come to this side and I also do the same, this will be negative 4x, then minus 2. Then bring this on this side such that the x becomes a positive. And then when this one goes this side, we shall have negative 2 minus 1, that will be a negative 3. So meaning x is going to be equal to negative 3 out of 4. Okay? And that is that. Then when we look at these two values here, for g, since we are putting g into the f, the x values must be less than 0.5. Okay, less than 0.5. But this one here is 0.25. So negative 0.25 is bigger than the negative 0.5. So meaning I'll dismantle this one here. Okay, I'll dismantle this value here, and then I take this x, which is equal to negative 3 over 4. But here I'll show this one that it is a quarter, but then it is rejected. Okay, and this is our answer. Then part B, find an expression for the inverse function of the composite. So first of all, fg of x, this one is equal to fg of x. This is what we had here, not so. So we are having this one here. So I will have 1 over 2x plus 1, okay, then squared, and then minus 1. Okay, so we are supposed to find the inverse of this. So we shall say, maybe let the inverse of this one here be what? By. So if it is equal to y, then I take this one this side. I will have x, which is equal to fg of y. In other words, interchange x and y. So we shall have x, then where there is x here, you put a y. So this will be 1, then out of 2y plus 1, then squared. Because you know, when I square 1, it is 1, then also square the denominator. Not so? Then minus 1. Then we are supposed to make y the subject of the formula. So bring this on this side. So we shall have x plus 1, which is equal to 1 over, then 2y plus 1 squared. Now we shall cross multiply, then 2y plus 1 squared. Okay, that one, then I will multiply it with x plus 1 here. Then I will say is equal to 1. Then after, I will divide through by this, not so. So it's better to just write this one here is equal to 1 over, then x plus 1. Then we can take the square roots on both sides. So we shall have 2y plus 1, which is equal to plus or minus, then the square root of 1 over x plus 1. And then to make y the subject of the formula, first take the 1 here. Okay, and then we shall have negative 1, then plus or minus the square root of 1 over, then x plus 1. And then after we divide by 1, by 2. And a function that has gotten an inverse must be a 1-to-1. Okay, so I need to choose from these ones. I mean, the sign that I'm supposed to get here, I'm supposed to choose 1. So the inverse of this fg here of x is going to be equal to, this is 1, then it's a negative, and then here we have 1 out of, then x plus 1, and then over the 2 here. So which sign are we going to put here? So I'm going to choose, of course, a negative, because when you come back here, the x values we are using, they are all negatives, okay? We are looking at this one, first of all, is the U-shaped curve, and its starting point is going to be 0, -1. Then we are looking at the left of it, okay, less than. So we are looking at the left side of these graphs here. So that means we are going to take the negative, as simple as that. Or I can actually write this one as, this one can be written as 0, I mean this -1 divided by 2, you will get -1 out of 2. Then minus, of course here we shall have root of 1 is 1, then out of, we shall have a square root of x plus 1 here, then it will multiply with this 2 here, okay? Because this one is over this, and also this one is over this 2. You see that? So this will be our inverse function here. And that is our answer. Let me first remove this one here. Then we put f of g inverse, then of x. That is that. Question 9, part A. A geometric progression is such that the second term is equal to 24% of the sum to infinity. Find the possible values of the common ratio. Now, sum to infinity is given by a out of 1 minus what? R. And they are saying the second term here, the second term, which is AR, okay, is equal to 24% of the sum to infinity. So that means I'm going to have AR, which is equal to 24% will be 24 out of 100. And then the sum to infinity is A out of 1 minus R. And so? Then this A automatically will cancel with that. Then we shall get, if we cross multiply, we shall get 100R. Okay. In fact, I can simplify this one first. So we have R, which is equal to, by 4, you get a 6. Then over 25. Not so? Of 1 minus what? R. So, and then from there, we can cross multiply, not so? If you cross multiply, you have 25R minus 25. Remember, first multiply these ones, then you multiply with the R, okay? So minus 25R squared, then this one will be equal to 6. Let us bring everything this side such that the coefficient of R squared becomes a positive. So that will be 25R squared, then minus the 25R, and then plus the 6. This one will be equal to 0. This is a quadratic equation. Let's see whether it is factorizable. Mod, then equation is 5, and then 3. Then we have 25, then minus 25, and then 6. So this one will be 3 over 5 and 2 over 5. So R will be equal to 3 over 5. And also R becomes 2 over 5. But give us the factors from which these roots come. So cross multiply, you will get 5R, then minus the 3. And then also cross multiply there, you have 5R, then minus the 2, which gives you 6. Then possible values of R, of course, these are the two. This one here, and also this one here. Part B, an arithmetic progression P has the first term A and the common difference D. An arithmetic progression Q has the first term 2 into A plus 1 and the common difference D plus 1. It is given that the fifth term of the AP out of the 12th term of the Q is a third. The sum of the first 5 terms of P out of the sum of the first 5 terms of Q is equal to 2 over 3. Find the value of A and the value of D. Now, the fifth term of P here is going to be A, then plus 4D. Okay? Then out of the 12th term, remember, it is supposed to be A plus 11D. But the first term of the of this APQ is this one here. So we have A, which is 2 into A plus 1, then plus 11 times the D. But what is the D for Q? Is D plus 1. Okay, so we shall put D plus 1 like that. Then we equate this one to a third. You see that? So we simplify this one here. We can even cross multiply. Then you have 3A, then plus 12D. Then this one will be equal to, when you multiply all through here, this will be 2A plus 2. And then plus, this will be 11D, then plus 11, right? Because we are multiplying by 1, so it remains. Then we can bring everything onto one side, and then we form an equation in D and A. Or maybe I can bring A here. We have 3A minus 2A. Then this one will be equal to, this is 11D. Then subtract this 12D. You see that? Then there is 2 plus 11, that will be a 13. So meaning here you will get A, which is equal to 11, of course this will be 13. Then 11 minus 12, that's a minus 1. So we shall have that one there. And this one is going to be our first equation. Okay. Then we also come to this one here. When we come to this one, we have sum of the first 5 terms. Let me actually extend this one here. Sum of the first n terms of an AP is n over 2 out of 2a plus n minus 1 what? D. Okay. So that is when the first term is A and the common difference is D. So let us substitute here. We are going to have, there are 5. So 5 over 2, then into 2A plus 5 minus 1, that will be a 4. Then D. Okay. That is for P. Then we are going to divide by 5 over 2, then into 2A. So we shall have 2, then times the A for Q is this one here. So times 2 into A plus 1. You see that? Then plus n minus 1, that will be 5 minus 1, that will be a 4. Then the D for Q is this one here. So we shall have into D plus 1 like that. Then I close the brackets. Then this one will be equal to 2 out of 3. Now this one will just go. Not so. And then we can cross multiply. So we have a 3 in here multiplying with 2A plus 4D. Then we have a 2 here. Okay. Then multiplying with everything here. So simplifying whatever is here, we are going to have 4A, because this will be 4, then plus the A, that will be 4A, not so. Then plus, there is a 2 here, and there is a 4 here, okay? So that one, no, it's not a 2 actually, it's a 4. 2 times 2, that's a 4 times 1, so that's a 4, then plus a 4, that will be 8, okay? So we have 8, then plus 4 times D, that will be 4D. Then we open the brackets, we shall have 6A, then plus 12D, then this one is equal to 8A, then plus 16, and then plus 8D. Okay, simplifying this one here, wherever there is A, I can put what? I can put D. So this implies that we shall have 6 into 13 minus, or let me first simplify, okay? Let me first simplify it. 6 minus 8, we shall get negative 2A, okay? Then this one is equal to, this is 8 minus 12, that will be negative 4, negative 4D, you see? Then there is a plus 16 here. Now I can substitute this one here. So that is negative 2 into 13 minus d. Then this one is equal to negative 4d, then plus 16. And then from here, we shall get negative 26 when we open the brackets, then plus 2d, and it's equal to negative 4d plus the 16. So bring this 4d this way, it will add to the 2d, and then we get 6d. Then when this one comes and adds onto this, 16 plus 26, that will be a 42, not so? So meaning d, when you divide all through by 6, d will be a 7. And then if d is a 7, then what is a? So therefore, our a is going to be equal to 13 minus the 7, which gives us a 6. And that is that. Question 10. Points A, B, and C lie on the circumference of a circle with center D. Show that the angle ABC is equal to 90 degrees as our part A. So if negative 2 and 3 is here, that is A. Then B is 3, 0. So 3 is on the right of negative 2, and then 0 is below the 3. So maybe I will have it down there. So maybe this is B, which is, let me just put it around here. B is 3, 0. Then C is 6, which is on the right of the 3, and then 5, which is even above this 3 and 0. So maybe C is around here. So that is C, which is 6, but 5. Okay, so I have something like that. I can now connect these points of mine here, like that. And they are saying that angle ABC, so this one has to be 90. So for perpendicular lines, the product of their gradient is always equal to negative 1. Okay, so I will say for angle ABC, for angle ABC equal to 90 degrees, then the gradient of AB times the gradient of BC has to be equal to 90. I mean negative 1. Now let us look at the gradient of AB. Remember, we get gradient by getting the change in y. So 3 minus the 0, 3 minus the 0, then out of the change in x, negative 2, out of, minus 3, negative 2 minus 3. So this whole thing becomes negative 3 over 5. And then the gradient of BC, we shall have the change in y, so 5 minus 0, 5 minus 0, then out of 6 minus 3. We have 6 minus 3, and this one will be 5 over 3. Now, let us see MAB, then times the gradient of BC. What do we get? We get a negative 1, so negative 3 over 5 times 3 over 5. No. Times, this is 5 over 3. Of course, you can see this one cancels with this, and then this one with that, and then we get a negative 1. So, by doing that, we have proved, because this is what we wanted. So that means AB is perpendicular to what? BC. You see that? Alternatively, you can use Pythagoras theorem. You find the length of this one, you square it, then find the length of this one, you also square it. Then after that, the length of this one, when you square it, is it the length of this one squared plus the length of this one squared? Because if you have x, this is y, this is z, then the x squared plus y squared should give you the z what? Squared. So you can also prove it that way. Okay, so that is that, but I've used the one of gradients. And then part B, they are saying that hence state the coordinates of D. Now in circle theorems, okay, in circle theorems we have what we call angle in the semicircle. So if you have a diameter, that is the line that passes through the center of the circle connecting the 2 points on the circumference, right? Then you draw here. In fact, let me make it much more beautiful. So like that, then you connect to the circumference of the circle. whether you put it here, okay, or you do like this here, this angle here will always be 90 degrees, okay? So this angle here is 90 degrees. So this is A, this is B, this is C, okay? So this simply implies that AC is the diameter. And since they said that D is the center of this circle, D is going to be the midpoint of that AC. D is going to be the midpoint of AC. So I will say D is the midpoint of AC, since angle in the semicircle is always 90 degrees, okay? Or angle subtended by the diameter at the circumference of a circle is 90 degrees. We also have this circle property, that angle at the circumference here, this angle here, when you look at also this one will be twice. So angle at the center is twice angle at the circumference, right? Now this angle here is 108. You see that? That means the one at the circumference has to be what? 90 degrees. So that is that. So let us find D. D is now going to be the midpoint of A and C. So find the average of the x coordinates. So we have -2, then plus 6 over 2. And then the average of the y coordinates, that is 3 plus 5, which will be 8. Then we divide by 2 and it gives us a 4. So this one will be D. Then 6 minus 2, that is a 4 divided by 2, that will be a 2. And then this one here is a 4. So this is our answer. Then find the equation of the circle. We need to find the radius. I can use the AC as the diameter. I get its length. Then we can find the radius. But suppose I can use any of these coordinates. I can use C, I can use B, I can use A together with D, then to find the radius of the circle. Because from the center of the circle to the circumference is all what? Radius. You see that? Okay. Now, let us look at A and C. So A is -2, 3. And then, actually not A and C. I'm looking at D. D is 2, 4. So the radius is going to be square root of the change in x will be this 2 minus -2. 2 minus -2. That one becomes a 4. Then you square that. Then plus the change in y, that is 4 minus the 3. So 4 minus the 3. Then you square that. Then this one is going to give us what? This is a 4 first of all. Then squared, that will be 16. Then plus 1, that will be 17. So we are having root of 17 here, okay? And then equation of the circle is given by x minus, now the center, remember the center is D here. So we shall have x minus 2 squared, then plus y minus 4, then squared, then this will be equal to r squared. So we shall get this root of 17 we have gotten, and then you square it. So meaning our final answer is going to be x minus 2, then squared, plus y minus 4, then squared, then this one will be equal to 17. That is that. The point E lies on the circumference of the circle, such that BE is the diameter. Then part D, find an equation of the tangent to the circle at E. Now, if you go back and look at this question, the way it was said, you look at this one is the stem, the main stem, okay? Now, they are saying that D is the center here. So if now they give us E, which is on the circumference of the circle, then they are saying that BE is their diameter. So let us first see our circle here. Remember, the circumference of a circle I mean the diameter. Diameter can be this one. Diameter can be this one, so long as it passes through the center of the circle. Okay, so already we have seen that we are having A here, which A is what? A is negative 2, 3. So negative 2, 3 here. That is our A. Negative 2, 3. Then we have our B here, which is 3, 0. So 3, 0. And then our D here is 2, 4. Then we have our C, which is 6, 5. 6, 5. Point E lies on the circumference such that B to E is a diameter. Okay, so if B is here, then maybe the diameter is here. Okay, so I can draw, of course, a line that goes through the center. Let me first actually connect these ones, because this one we know it is what? 90. Then also we are going to have this BE now going through the center, this line here, then to E. Then we are going to have E here. Okay, and then they want the equation of the tangent here at point E. Now this is just a sketch, so the tangent here, it can be like this, it can be like that. So this is not the perfect one. So I don't know whether the gradient of the tangent is negative or positive, but this is just a rough sketch. Okay, now we need to find the coordinates of E here. So since BE is the diameter, that means this D is the midpoint of E and what? And B. So that means I'm going to have A, then plus the 3 divided by 2. Then this one will be equal to 2. In other words, how can I get the coordinates of D here using these two? So I will say this A plus this one divided by 2, then I'll get the X coordinate. The same that I will do to get the Y. We shall have B, then plus 0 out of 2. Then this one will give us what? Will give us a 4. So when we cross multiply, then B becomes 8 here. Not so? And then A here is going to be cross multiply. You'll get 2 times 2. That's a 4. Not so? Then minus a 1. Then you get 4 minus 1, you get 4 minus 3, you get a 1. So we shall get that. That's our E. Now we need to get M1. You know, for the circle, the tangent is always perpendicular to the radius. So I need to find a gradient of this one here. Either you get the gradient of this diameter or the gradient of the radius. It's the same. So M1 is going to be equal to 4, then minus 8, which we have gotten here. Okay, then out of what do we have? We are having the change in X is now 2, then minus the A, okay, which A we have gotten here as 1. So what are we going to have? Negative 4 over 1. Do you see what we are getting here? Negative 4. That's the gradient of this. So I told you this one is just a rough sketch. So that means this diagram of mine here, I can rotate it a bit, maybe like that, such that the diameter or the radius, they have a decreasing what? They have a decreasing gradient. So it is like that. And a line that goes like this has a negative gradient. Then a line that goes like this has a positive what? Gradient. So I'll take this one to be like that. That means the gradient of the tangent has to be positive. So M2, which happens to be the gradient of the tangent, will be negative 1 out of this negative 4, which becomes what? A quarter. You see that? Then using y minus y1, which is equal to m into x minus x1, what are we having here? we have y minus, remember, to find the equation of a straight line, we need at least one point through which a line passes, and also the gradient of that line. So the point through which the line passes is E, which is 1/8. Not so? That is 1/8. So our y1 is 8, and then the gradient, we have gotten it as a quarter, and then we have x here minus 1. I can even leave the answer here like this, but let us continue and then make y the subject of the formula. This is a quarter of x, then minus a quarter here. But then you take the 8 this side, it adds to this one here. So meaning the equation of this straight line is going to be a quarter of x, then 4 times 8, that is 32. Minus 1, you get 31. So positive 31 out of 4. And that is that. Question 11. The diagram shows part of the curve with this equation here where k is a positive constant. Part A, find the coordinates of the minimum point of the curve, giving your answer in terms of k. Now, what do we have to do here? Coordinates of the minimum point of the curve, that is differentiation. And we know that for stationary points, because stationary points can be minimum or maximum, right? So for stationary points, dy dx is equal to what? 0. Now let us differentiate here. You drop the power, so we shall have a half, then x to the power of a half minus 1, it will be negative a half, right? Then plus k squared. Now this number many students missed. They also differentiated this k. K is a constant. They told you it is a positive constant, so don't tamper with it. Just differentiate this x here. So times, then the negative a half, and then x. This one is power negative a half. So when you subtract a 1, you'll get negative 3 over 2, right? Then you equate this one to 0. Then from here, we are going to get 1 over 2, then x power half, and then minus, this will be k. Okay, in fact, I can take it the other side, and I say this one is equal to k squared, then over 2, x power 3 over 2. Using the rules of indices, this one can come down, and then it becomes a what? A positive. Okay, now here we are supposed to solve and find x. So don't you think this 2 actually will go with this? Yes, it will. Then when we cross multiply, we shall have x power 3 over 2 out of x power a half. Then this one will be equal to the k squared. And then from there, using the rules of indices, we shall have this one minus that. Also, you subtract the powers. So this minus that is equal to that. So 1.5 minus 0.5, you get a 1. So that means x is equal to k squared. Okay. But they said coordinates. So that means I need to get the y coordinate. So what will be our y for x equal to k squared? So this will be k squared, and then there is power half, then plus k squared, then times, this is k squared, but then it is power negative what? A half. So this one will give us k, then plus, this is k squared, times, this one is going to be k power negative 1, because you will multiply these powers, right? Then when I multiply them, so I'm going now to add these powers. So 2 minus 1, what do you get? Don't you get 1? So you have a k here, meaning y is going to be 2k. So the coordinates of the stationary point, we are going to have k squared and then 2k. That is that. The tangent at the point on the curve where x is equal to 4k squared intersects the y-axis at P. Then part B, find the y coordinate of P in terms of k. Now, a tangent has gotten its gradient equal to dy dx, okay? Because at the point of intersection with the curve, they are having the same gradient. You see that? And we get the gradient of a curve using differentiation. So for x, which is equal to 4k squared, now what we are supposed to do here is actually to find the equation of the tangent, and then we see where it intersects with the what? The y-axis. As simple as that. Gradient of the tangent at P is going to be equal to dy dx, which is equal to, we go back and check here, dy dx is this one here, not so, which I can write as 1 over 2 root of x. We have 1 out of 2 root of x. Then this one here is k squared minus k squared out of 2, then x power 3 over 2. You see that? Or I can actually write this one as x power half for uniformity. Now, x is this, so we substitute in here. But is this one a minus? Yes, there is a minus here, okay? So we shall have 2 out of 2, and then our x is 4k squared, then power half, then minus, this is k squared out of, this is 2 into 4k squared, then power 3 over 2. What do we get here? Of course, this one will go with that. How did I write this 2 here? It is not there. We are having a 1. Okay, then here we shall have the square root of 4 is a 2. Then times the 2. Won't that be a 4? So we have 1 over 4. Then the square root of k squared will be k. So we have k here. And then here we have k squared out of square root of 4. What do you get? You get a 2. Then 2 cubed, you get 8. Now 8 times the 2, we have a 16 here. Then square root of k squared, you get k. Then times this one, you get k cubed. Not so? This will be k cubed. So meaning this one is going to be 1 over 4k minus, of course, this one will go into this one, and then we have 1 over 16k. Not so? And we can simplify this one into a fraction. Okay, now let me reserve some space. I'll bring this one down here, then bring this one here, then I'll bring this one right up here, and then what else? I'll have now this one here, and then this one there. I think I would have reserved something. What do we have? The LCM here is 16k, okay? Because this one can go in here. So if you say 16k divided by 4k, don't you get 4? We get 4. Then times the 1 up here, we shall get our 4 here. Then minus 16k divided by 16k, you get 1, not so? Then times 1 there. So that means this one is 3 out of 16 together with the k there. That is the gradient of the tangent. You see? Then after getting this one, we now need to find the equation of the tangent. Equation of the tangent. Now, we have this 4k squared. What is the y coordinate? Do we have it before? X is equal to, no, we don't have it. So we need to get the y coordinate here. Okay, let me leave this one here, and we say for x, which is equal to 4k squared, then y will be equal to what? Go back. This is the one here. So we shall have x power half. So this is 4k squared power half. Then we have k squared and x power negative what? A half. So we shall have plus k squared, then x, which is 4k squared, is to the power of negative what? A half. So what does this one give us? So the square root of 4 is of course a 2. And then the square root of k squared is k. Not so? Then plus, what shall we get from here? we shall have the square root. This one actually can be down. You have something like this, 4k squared, then power a half. So this one can give us k squared, then out of here we are going to have 2k, okay? And then this one will be k over 2, because this one will go into that. So k over 2. We have here k over 2. Then after that, what else do we have? We are going to have, this is 2 plus 0.5, that is 2.5. So I can have 5 over 2 of k. So that means we are going to have, okay, oh, I made a mistake here. This gradient of the tangent is not at p. It is actually at x, which is equal to 4k squared. And the y coordinate is this one here. So now we continue to find the equation of the tangent. So we have y minus y1, which is equal to m into x minus x1. This one is passing through the point 4k squared and then 5 over 2 of k. So you have y minus the y1 is this one we have gotten, okay? This one here. So we have 5 over 2 of k, which is equal to the gradient. We got it here, 3 over 16k here, and then into x minus what? The x1 is 4k squared, 4k squared. Then if it is intersecting y-axis, we know that on y-axis, x is equal to what? 0. So wherever there is x, then you put the 0. So we shall have 3 over 16k here, then times the negative 4k squared. Are we there? Because this one has gone, we have put 0. Then let this one cross the equal signs, so it will come this way as a plus. So that will be 5 over 2 of the k. What do we get here? 4 can go here 4 times, not so? So we shall get negative 3 over 4. You see, negative 3 over 4. Then this guy will go here. We'll reduce that by 1. So negative 3 over 4 of k, then plus 5 over 2 of k. Now, we simplify this and this, and then we get what? Negative 3 out of 4, then plus 5 over 2. You get 7 out of 4 of k. So that means y is going to be equal to 7 out of 4 of k. That is the y coordinate of that point P where the tangent crosses y-axis. As simple as that. The shaded region is bounded by the curve, the x-axis, and these lines here. Part C, find the area of the shaded region in terms of k. Of course, the shaded area, we are going to integrate. So it is going to be the integral from these 2 points. Even when you check here, we are integrating from here then to here. Those are the limits. So we shall have 9 over 4 k squared, then to 4k squared, and then the equation of the curve here is this one here. So if it was between any other line here, then we would have subtracted. We get this one here, then subtract the equation of this line, okay? But even here, when we are not putting any other, we are also subtracting the equation of this one, which is y is equal to 0, you see, but we don't put it there. Now, what do we have? This is x power half, then k squared, then x power negative half, and then with respect to x. So when you're integrating, take away the integral sign. So I'll create the square brackets, increase the power by 1, it becomes 3 over 2, divide by the new power. Then you also do the same here. Just like I said before, this one here is a constant, okay? So just integrate this, leave the k. So plus, this will be k squared, and then x here. When you add a 1, this one will become a half, and then you divide by that new power. Then you put the limits, 4k squared and then 9 over 4 of k squared. Then we shall somersault this 2 here, and then we have 2 out of 3, then x, this is 3 over 2, then plus, again somersault this one, then you have 2k squared, then x to the power of a half, then you put your limits, 4k squared, and then the 9 out of 4 of k squared. What do we get here? Wherever there is x, I'm putting this, right? So we shall have 2 over 3, then I put 4k squared power 3 over 2, then plus, this is 2k squared, and then 4k squared to the power of a half. Then after that, when I'm going to the lower limit, I put a minus, so put this one wherever there is x. Then we shall have 2 over 3, then there is, our x is now 9 out of 4. Let me just do it like this. 9 out of 4 of k squared, then 3 over 2 as the power, then 2k squared, then we have 9 over 4 k squared, and then this is a half as the power. Now we begin. Square root of 4 is what? 2. Then 2 cubed is 8. Not so? Then 8 times 2, that will be 16. So I will have 16 over 3. Then let's go to k. K squared here, the square root of that will give us k. Then cubed will be k cubed. Then we go to this one here. Square root of 4 is a 2. Then 2 times 2, that is a 4. So I will have 4 here. And then k squared here. Okay, before that, that is the square root of k squared. That one will give us the k, right? Then times the k squared, that will be k cubed. Then we subtract, we go here. Square root of k squared, that one will be a k. And then cubed, that will be k cubed. So let me first put the k cubed there. Then square root of 9, you get a 3. Then 3 cubed, that will be a 27. Also, so we have 27. Then how about this 4? Square root of 4 is a 2. Cubed is 8. Not so? That one will be 8. Then we are multiplying by 2 over 3, which is here. So this 3 can go here 9 times. This one can go here 4 times. So we are going to get 9 over 4 here. So we shall have 9 over 4 k cubed there. You see that? Then next, we go to this one here. Square root of k squared, that will be k. Then times the k squared. Again, that one, but there will be a minus because this one affects everything inside here, right? Then I will have my k cubed first of all. Now let's go to the numbers. Square root of 9 over 4, that will be 3 over 2. Then there is a 2 here, okay? Then that one will cancel with that, then we get a 3, not so? So meaning here we shall get 3k squared. 3k cubed. Now we need to get 16 over 3, we add it to a 4, minus 9 over 4, okay? Then minus 3, this whole thing here. They all have the k cubed. So this one gives us what as a fraction? 16 out of 3, then plus 4 minus 9 over 4, then minus 3. This one gives us 49 over 12. 49 out of 12 of k cubed. And I will leave it exact, just like that. And this is it. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.